Welcome, everyone. My name is Sergio Delamo. I am a member of the Micronaut core team at Object Computing. I am joined today by Bernd Rucker and Tobias Schaefer to talk about Camunda Micronaut integration. Pretty exciting for me because this is a completely community-driven endeavor. So it's cool to see that when you work on a project that third parties start to bring the project to places where you didn't envision the project to go. And we will learn, at least I will learn a lot about processes automation because in the poll that we currently have about the Camunda experience Micronaut integration, I will probably vote Micronaut plus Camunda minus. So we have a poll open. Please use it. We said it in the beginning, but we are recording the webinar and we will be publishing to our YouTube channel. We have a Q&A. So Zoom has a Q&A section on the bottom. Tobias and Bernd will be doing most of the talking. So I will be keeping an eye on the chat and the Q&A. So please, if you have any questions, write them in the Q&A because that give us the options to basically flag them as answered. And I will basically relay those questions to both of them. If you don't have a question, you can of course use the chat. I will be keeping an eye on the chat as well. And yeah, please vote in the poll. I will end the poll probably in a couple of minutes after we are done with the introductions. And without further ado, let me pass the baton to Tobias. So thanks everyone for joining.
So thank you, Sergio, for the introduction. Hello, everyone. So my name is Tobias. I'm a consultant at Novatec, mainly doing process automation. I'm living in Germany, in Stuttgart. And I'm passionate about the topic business process management and all kinds of related topics. At the same time, I like pushing technical innovation around in the JVM ecosystem. And at the beginning of last year, I looked into Micronaut and I liked it. And now I'm leading the open source project, which is integrating Micronaut and Camunda. And I'm very happy that we have a lot of participants in here today. You're probably quite curious what we're going to present. I'm looking forward to it and quite excited that Bernd has joined here as well. So Bernd, maybe you just say a few words about yourself.
Happy to.
As well.
I just saw, my name is Bernd Rücker. I'm German too, as you can see with the umlaut. We both have umlauts here. But I'm co-founder and chief technologist of Camunda. So I'm basically doing process automation, I always say, all my life. So I started already during university, doing a lot of things with workflow engines. And I co-founded the company and contributed to a couple of different open source workflow engines over the last 15 to 20 years. Seen a lot of customer projects. That's my background in a way.
Okay, perfect. Then I'll start with a small motivation and I'd say that we close the poll at the end of this slide. So at Novatec, we successfully use Camunda for a lot of our process automation projects. We're actually a platinum partner of Camunda. So it's a new certification which was given out, I think, last week. So we're quite proud of that. We're working very closely with Camunda. And besides BPM, we're of course doing a lot of other consulting topics at Novatec as well. So we're basically consulting in various disciplines that you need to build professional software. At the same time, we also apply software development to develop tailored solutions for our customers. And actually, it was only in December last year that my colleagues Carlos and Silvio presented here at Object Computing a webinar about Micronaut in action with their good experiences with Micronaut in production. And so we basically started an open source project to build a bridge between these two technologies, between Micronaut and Camunda. And we're quite curious how this will work out. So we're basically standing, if you want to say that, on the shoulders of giants. We have Micronaut and we have Camunda, and we're basically just building the bridge between the two. Okay, so Sergio has just closed the poll and we can see the numbers. So 34% are familiar with Micronaut, but not Camunda. So it's basically the Micronaut community. Then 27% say, I don't know Micronaut, but I'm familiar with Camunda. That's basically more or less the Camunda community. Then we have 17% which are familiar with both. That's quite nice. And I'm especially happy that there's 22% in here who don't have a clue about any, but just curious about the topics. And I'm quite sure that we have some interesting stuff for you as well. So very nice. Okay, Sergio or Bernd, you want to comment something on the poll?
No, I think it's quite what we expected. So a lot of people with different backgrounds. It's cool that, so from my point of view, it's really nice to have some people who don't have experience with Micronaut. So I hope, hopefully this will help you to understand what the framework has to offer better. And as I was saying in the beginning, it is nice when the framework is used for reaching a different community. Yeah, I am, as I said, I am in the Camunda minus section of the poll. So let's see what we learn.
Okay, then let's come to the agenda. So basically we have about 90 minutes of time for presentations, demo, and discussions. The first part will be done by Bernd, who will be basically addressing the Micronaut community, which does not have that much experience with the topic of process automation. And I'm quite sure he's going to convince you that process automation can be a very important building block in your architecture.
Let's see.
Let's see, right. And then I'll continue with the second part. We'll look into the open source project itself, talk about it, do a live demo. And if you're curious about it, how we actually built the integration, then that last part is for you. That will be about an hour in total, Bernd and me, and then we have about half an hour left for open discussions. Bernd, it's basically now your turn. I'll end my screen share and then you can now continue with your slides.
That's what we do. There we go. You should see my screen, right? Cool. I once didn't ask it in a keynote and then I forgot screen sharing. Since then I always ask again, even if that's kind of silly. Yeah, thanks everybody for joining. Happy that you're here, and quite a lot of people actually. Pretty cool. I wanted to give a very quick introduction into process automation. I don't want to bore you with any of the details. I just want to walk you through a couple of ideas here that hopefully set the scene for you as well. So what I normally like to start with is this very small story, which I really experience a lot of times, but you could also call it a thought experiment for you at home at the screen at the moment. So for example, imagine that you're tasked to build a small service. Let's say you are tasked to build a payment service. You might call it microservice. And that should offer a REST API for other services, like, for example, order fulfillment to collect money for orders you want to ship, right? That's your task, build the payment service. And this payment service should leverage an existing credit card service, which also has a REST API because you don't do credit card handling yourself. And let's also assume that's somewhere in the internet, like a managed service, like Stripe or whatever it is. That's not an uncommon scenario, actually. And it looks easy, right? So you have that one service, provide a REST API, consume a REST API. And the thing is that it's not as easy as it looks. Not a surprise, you have remote communication here, and especially if that goes like long ways into the internet, that's quite unreliable. There are a lot of good sources talking about reliability of distributed systems. So you shouldn't, or no, the other way around, you can't count on the service to be available at the moment you want to call it. So you have to cope with that. So one option could be you just pass on the problem to the order fulfillment team saying, hey, we can't charge a credit card right now, so we can't collect money for you. That's an easy solution, but it's probably not a very good one, because now it's kind of the hot potato. It's passed on to order fulfillment, and they have to sort it out. So that's normally not what you want to do in that situation. If you have to handle this in payment, you might want to do retries like immediately. There are a couple of frameworks providing that, but then still, if the service is not available for, let's say, a couple of minutes, it has an outage, you can't reach it. And if you want to solve that, what I see happening very often actually is that, okay, if I want to solve that, I have to remember some state. Like, I create a database table where I save everything in there, saying, okay, I can't, or whenever I want to retrieve payment, I put that request in a database table saying, okay, I haven't yet collected that money. Then I need some other component like a scheduler to look into the table saying, hey, there are open payments I still have to collect. So I then call the credit card handling. If it doesn't work at that moment, you can retry it later on, because now it's persistent in a database. And if you do this, you start building things like you have the database table, you have a scheduler. You might even encounter a situation where you have like weird data in the table or some exceptions basically bubbling up, so you can't process any payments anymore, for example. Then you might have to build a script in order to find these problems and fix them. If that happens, might even be that some business stakeholders approach you saying, okay, I want to have an overview of all the open payments that are uncollected in order to understand what's going on here. So you might have to add some reporting, due dates, and so on and so forth. So there are a lot of things to build around for this really easy requirement, right? And I see that happening all the time. And this brings you into a mess of a pile of code, which is really hard to maintain. It's not easy to build in the first place, especially at scale, for example, but it's especially not easy to maintain. And what's the alternative? And that's, I mean, I'm the process automation person, so I'm talking about workflow engines. A workflow engine is a component you could use. And I mean, we see how that technically works later on. I spared a lot of the details because Tobias is showing that anyway. But a workflow engine, in essence, can keep state persistent and it can schedule stuff. And then it can provide process models, like blueprints of how a process should run, like with tasks in a sequence. And then such a workflow engine can run instances on top of that. And you can imagine it a bit like this. Oh, the animation is broken, but you write some code, and you will see that later on, like normal Java code, for example, where you say, hey, I want to start a new process instance, for example, for a payment process. And this payment process is defined somewhere as a model. Then you start an instance, which is normally referred to by a so-called token. So basically a marker where I am in the process. It starts in the beginning and then it moves through that model. This is also stored persistently. In the case of Camunda, it's a relational database. So it uses a data source you already have in your application, for example, in order to store, hey, there's one process instance currently waiting in charge credit card, for example, right? And then the next thing you also have to do, you provide some code and attach it to these tasks. Like, for example, charging a credit card, what does that mean? And then you can implement some code, and that's a bit of pseudocode here, to be honest, but you will see the real code later on. It's relatively the same. Then you can write some code in order to express what that means. And that can be Java again in order to call a REST API or whatever you need to do here, right? So that's kind of the core idea of the workflow engine and how it works. And you could leverage that also for this kind of problem, like, hey, the credit card service might be flaky. Right. The interesting thing is, I always love starting with that example, because my impression is that it's at least easy to understand for developers, and it's not such a, hey, we have this end-to-end business process, a huge order fulfillment thingy. It's a very small technical integration problem, but you already see the value a workflow engine can bring. So long-running capabilities, I can wait for things, for the service to become available, and visibility, I can see things. And now we can look at use cases you can do with that workflow engine. And what I just showed was basically this like very easy integration problem. There you leverage long-running capabilities, not so much the visibility. You had one task, kind of boring. But of course you have other use cases. Like I'm not talking about that today at all, but business transactions, sagas in a microservices world, like restoring consistency, super interesting. Process orchestration or microservices orchestration, right? That's more these end-to-end business processes you sometimes think about. There you leverage not only the long-running capabilities, but also visibility and some others, right? What I always like to point out, it's not about graphical programming. So normally, if you don't need long-running capabilities, if you don't need to wait, if you don't need the state, a workflow engine is normally not the tool of choice, right? So that could hopefully give you an idea what you can do with that. Right, I always have that slide in there, but I think it's obvious. I said that earlier. I'm co-founder and chief technologist of Camunda. We're an open source process automation vendor. So we have a workflow engine, and that means I'm quite biased for certain things. Keep that in mind. If you want to reach out to me, there's my Twitter handle. You can always tweet me, send me an email, right? If there's anything you want to ask, which you don't come to in the Q&A. Camunda, I think Tobias also has a quick slide, so I'm going over that very quickly, but we're an open source process automation platform. We're pretty mature and widely adopted. I name that because sometimes people came across us a couple of years back, and we've grown significantly. So there are a couple of numbers where you can see that we're really worldwide. We have a lot of enterprise customers, big installations, a huge community, especially a huge open source community. So it's a good place. That's it. One thing I wanted to quickly touch on are microservices in particular. And I don't want to define microservices here too much. I mean, you're probably familiar with that. So instead of building monolithic applications, which basically put a lot of functionality in that one box, you untangle it and say, okay, I want to have different services. They implement one business capability and as isolated as possible. So that means if I want to change a business capability, ideally, I only change one service, and I probably don't even have to talk to the others, and I don't have to coordinate deployments. I don't share resources. So I have my own database. I have my own container. It's one team caring about the service. I don't have to involve other teams in order to make a change in that one microservice. That's the basic idea, right? And that's the world we are currently living in. And we see that this is extending like all the time. So we have these microservices, but we also have other components which might not be called microservice. So for example, these external services like the credit card service. You have a lot of legacy or standard software on-prem, which hopefully provide an API. If not, there are tools like robotic process automation that can control user interfaces and then provide an API. You have serverless functions, you have this and that. So you have a lot of components you need to stitch together in order to automate, for example, business processes. And that's what I'm looking at most, actually. How can we combine all these things together that we get something useful out of that? And that's an interesting problem, actually. And I always make this example, and I go over it very quickly, but there are a couple of resources if you want to look it up later on. So imagine order fulfillment again. Like you have a couple of microservices: checkout, payment, inventory, and shipment. And if you look at microservices, one thing that's very common at the moment, very hype, is event-driven systems. So making reactive microservices. And that has a couple of good use cases. For example, you could say all of these microservices, they emit events like, hey, somebody placed an order, hey, somebody paid, somebody, we shipped the parcel, right? All interesting domain events. And then you could build, like they are put on an event bus, and then you're built like one component, one microservice, for example, which says, I subscribe to all of these events to send out the notifications to the customer, like the emails. And then you have that in one place, which is quite great, actually. And you don't have to think about how to send notifications within the payment microservice. So that's a good use of event-driven. The thing is, there's not everything is great in event-driven architecture. So the one thing, you still have to implement long-running behavior. I'm not talking about that anymore because I've talked about that in the beginning. So you might have to wait for a couple of events to happen within a certain time frame, for example. That's still something you have to implement. Workflow engine can be very handy. But what I want to talk about briefly are event chains. So you can implement business processes by basically having a chain of what I call a chain of events. So checkout says, hey, somebody placed an order. And then the payment service could subscribe to that saying, okay, if somebody placed an order, I retrieve money. And then it emits another event and eventually says, okay, if somebody just paid, I basically pack together the goods and so on and so forth. And by having a couple of these event subscriptions, basically a process emerges out of these events flowing around. The problem I have with this view, and that's what I said, pretty famous at the moment in a way, is that you don't see the process anymore. It's really hard to see it. It's quite impossible to change it sometimes. And I'm not going into the why too much. I have a couple of resources on that. But the important thought here is if you want to have like order fulfillment, and if you want to have somebody responsible for order fulfillment, if you want to have somebody, some team to ask, hey, why don't we fulfill orders in time? Why do we don't we like ship within 2 days? Why do we need 4 days sometimes? What is with failed orders? If some order hangs somewhere in between, if you need that responsibility, you should probably end up with a microservice implementing the order fulfillment, like end to end. Right? And this might still react to events like, hey, somebody placed an order. Okay, now I have to fulfill it. Cool. But then you also need to control certain behavior in the overall system, saying like, okay, now the first thing we have to do to fulfill the order is retrieve the payment for me, please, payment microservice. Then payment does something, and then I get back the message, okay, payment was retrieved successfully, and then order fulfillment also, okay, the next thing I have to do is fetch goods from store, okay? And that's what's called orchestration. So whenever you have these events, you react to things, that's what's called choreography, and that's a very useful way of communicating in certain requirements, but sometimes you also need to coordinate, to command other services to do something for you, and then you have orchestration. Now, if you combine that with the very beginning, you have that, okay, I want to have payment doing something for me, but this might be a distributed system. This might be a service that needs time to retrieve the payment. So that makes everything here long running. And that's why this orchestration logic very often is also long running. And that's why it makes a lot of sense, again, to use a workflow engine like, for example, Camunda, to do this orchestration, where you could say, okay, I send out a command to retrieve the payment in order to do order fulfillment, and then I wait for the payment to be received. And only if that happens, I fetch the goods next, and so on and so forth. And now we can really wait for things. You can even model timeouts and so on and so forth. I'm not going into all of these details. Okay. And again, the implementation of that might be simple Java, what that means. This is a Spring Boot example. I'm sorry for that. I have Spring Boot examples. Tobias shows the great stuff later on. But this is a Spring Boot example using Camunda Cloud, sending some messages via Kafka, for example, if that's what you want to use. And then you have that one place where you can understand the process, where you can change it, where you can operate it, right? And so on and so forth. And it doesn't mean, and that's sometimes the conception people have, if I say process orchestration, process automation, people think of, hey, there's this central workflow engine. It's a huge machine somewhere in the enterprise. We only have one. And that's not true. For me, a workflow engine can be, as we will see today, kind of a very lightweight library you embed in your one microservice if you write it in, for example, Micronaut. Right? And then it can start it up, and you have the long-running capability provided by this kind of engine, right? And then all the microservices might have capabilities like this, or might need capabilities like that. Cool. That was very quick. I totally agree. If you want to learn more, I mean, Tobias will go into really the great demo to see how that really works, and I'm looking forward to that. If you want to fly on the conceptual level, I can totally recommend this one. I'm currently in these are my evenings at the moment to finish the copy edit there. We're in the last month of publishing that book, Practical Process Automation I can recommend it. But there are a lot of things also if you want to look around, like how does that really work? Where do I apply it? Which use cases? That's a good resource. And if you go to the website for the book, I always link examples for a couple of things. So for example, the order fulfillment I was talking about, you can find a full working example on GitHub, link there. So if you want to dive more into that, that's a link. Yeah, that's more kind of the marketing slide I copied over. But I find that interesting. So if it's totally independent of the industry you're working on. It's also totally independent of the size of the company you're working on. So we're having these kind of like what we're doing with it in terms of what kind of processes all across the board. You find a couple of probably triggers for you there. So as a quick summary, use a workflow engine whenever you have some long running problems. For me, that makes a lot of sense, especially if it's lightweight and can integrate into your architecture very easily. Orchestration helps to avoid chaos, especially in a microservice architecture. Right, and you can do that with Micronaut now. That's pretty awesome. And I'm super happy that actually Tobias stepped up and also organized this here. So I don't want to bore you with any more slides, and would love to hand back to Tobias here.
Thank you very much, Bernd. I like that talk very much. I admit I have seen it before in a very similar way, but I think it's convincing.
But I talked faster this time.
Yes, you did. Okay, so please have a look at Camunda in detail. If you're convinced now, I'll now continue with the Micronaut Camunda integration project. So what is the vision that we're currently following? We want to bring process automation to Micronaut. And why are we doing that? Because we are actually convinced that process automation is a good thing. And if we bring this to Micronaut community, they can basically also profit from the process engine or workflow engine, which will do a lot of good stuff, which Bernd mentioned previously. So basically, we're building another building block, which you can use in your Micronaut projects. And we're currently not aware of that there are other integrations for Camunda and Micronaut. Actually, I don't think there are any workflow integrations at all for Micronaut at the time. So this is some kind of unique selling point currently if you are convinced of Micronaut and you want to use that. And while preparing the slides, I stumbled across the vision of Camunda again, which is automate any process anywhere. And Bernd, right? I think that should also include Micronaut, right? You basically said that, right?
I think anywhere should include Micronaut. Totally.
Okay, so we now have two slides. Basically Micronaut in a nutshell and Camunda in a nutshell for those of you who either know one or the other. So what is Micronaut? Micronaut is a JVM-based framework which you can use to build microservices or serverless applications. The second part is in brackets because we're not targeting that right now with our integration. What is special about Micronaut? It's basically the ahead of time compilation feature, which means that you pull out the complexity which you usually have during runtime into the build phase. So for example, Spring Boot does a lot of magic. It uses reflection, it uses runtime proxies and so on, and does all this at runtime, meaning that this requires more memory. And of course, the startup is faster. And if you now move that into the build phase, your startup is potentially faster. And of course, you also have a lower memory if you use Micronaut when comparing that to other solutions. However, of course, the build is a little bit slower because it has to be done during the build, but incremental build actually works quite well there. And Micronaut itself, it's released as with the Apache license, so you can actually use it quite well in all your projects. Sergio, would you like to add something?
Yeah, sure. So about what you said, the Micronaut Camunda integration that you built is the only one that exists. I'm pretty sure about that. And it's also the only engine that we currently have an integration with. So Micronaut, for those new to Micronaut, is a JVM framework. We say it's a foundation framework because you can build many kind of Micronaut applications. So the typical Micronaut application is a web application where you use the native runtime. But you can build serverless applications, you can build CLI applications, you can use Micronaut within an Android application, for example. You can use Micronaut HTTP client outside of a Micronaut application. You can use Grails 4 sets the Micronaut application context as the parent context of the Spring context. If you are into Rails, that may be of interest to you as well. So it's like, so what I wanted to convey is also you can deploy, for example, Micronaut applications to many cloud environments. So you can deploy Micronaut applications to AWS, but also to Azure, to Google Cloud. Micronaut is a multi-language framework. So you can write Micronaut applications in Java, in Groovy, and in Kotlin. And it's also build agnostic. You can build Micronaut applications using Gradle or using Maven. And you can test your Micronaut applications with different test frameworks. I, for example, like a lot of Spock, but you can use JUnit 5, or if you want to use a Kotlin first testing framework such as Kotlin Test, that works as well. So yeah, the home of Micronaut, so I'm not going to speak much more, but the home of Micronaut is micronaut.io. We have good documentation there with step-by-step tutorials to help you get started. So yeah, and of course you can reach us in Twitter. So I think you will like what you see there. And I think just to finish, I think there are two important benefits of Micronaut. One is it will save you money because Micronaut applications have a low memory footprint. It will allow you to go places where you were never before, because Micronaut applications are really fast to start up. And that's not only important in production, it's also really important in development, because the fact that Micronaut applications start up really fast will make your functional tests start really fast. That will make your developers write more functional tests, and that in turn will make your applications more robust. So it's like a virtuous life cycle there. I will be in the chat. If you have any questions about Micronauts, please feel free to reach out.
Perfect. So you can see that Micronaut is a lot more than you might see at the very first glimpse. Okay, then we come to Camunda in a nutshell. I think Bernd has said most of this already. It's a process automation platform. It implements BPMN 2.0, which is an ISO standard. And I think what's very important, it can be basically embedded very easily into a JVM-based application, because it's basically just a dependency which you can use in its very core. And it's the same as Micronaut, it's released as the Apache license. So there you can also use it in all kinds of software. Okay, then let's have a look at a picture. It's basically the architecture of our integration. So if you create a Micronaut project, you might usually use something here, which is the Micronaut core. And you will usually use some kinds of APIs which you put on top of that. So those are basically those two blue rectangles which you have here. And what we have done is basically now include the Camunda process engine. So this is this one into your application. And we provide a Micronaut Camunda integration which sits between the two and which wires these two together. And then you as an application developer can then put your process models into the application, and you can write the application code basically similar to that what Bernd has already mentioned previously. And all of that then goes through the Hikari connection pool against a relational database. What we basically make sure is that Camunda and Micronaut both use the same transaction by default. So we make sure that we have a transactional behavior there and data stays consistent. So what are the key features that we provide? As I said, you can very easily integrate the integration project into Micronaut by simply adding a dependency. And with that, you basically get three things. First of all, you can inject all those Camunda services which are available to start your process instances, to correlate messages, and so on. And you can simply inject those. The second thing is basically the other way around. So you can interact with Micronaut from Camunda by referencing beans in your process model, and these are then resolved and will be used to execute code. And third, I already mentioned that the integration takes care that Micronaut and Camunda use the same transaction so that we have data consistency there. So we receive a lot of support from the open source community. Of course, we have a lot of people from Novatech who have sometimes just helped out somewhere with code contributions. We've had some discussions. I like those a lot, so thanks for that. And I'm also very happy that we've had some pull requests from third-party developers who just by coincidence came across our project, liked it, and found something to do there. And we also get a lot of help from Gitter and GitHub discussions. So thanks to Graham, Ivan, James, and Jeff, I think we have a lot of support there, and it's very, very helpful. I'm very grateful for that. So thank you for that. And basically here on the right-hand side, you can see the current contributors. One of them is a depender bot. I think that's the one here, which is keeping the dependencies up to date. Then on the other side, we also support the open source community. So during the last year, we've created a lot of pull requests. You can see the bubble here at the bottom with the 8. Those are basically all kinds of typo fixes, mainly, I think, against Camunda. And then we also have a number of more pull requests which have been integrated, which actually have also changed the behavior of Micronaut, for example. And I'd also like to say thank you here at this point of time for being very responsive, Camunda and Micronaut. I think that's very helpful. And it's nice that as a developer, you see that your work is being integrated and you get very fast feedback. So of course, this question comes up quite often. How fast is it? And if I don't answer fast enough, the people ask, how fast is it compared to Spring Boot, for example? It's hard to answer that because the startup time just depends on a lot of things. So for example, even the bootstrapping of the process engine takes a few seconds. This is currently due to very slow MyBatis initialization, which is passing XML files sequentially. If you initialize the process engine lazily, your application will be up in less than a second. So if that convinces you, then yeah. Of course, the initialization also depends on the usage of the web applications and the REST API. So if you use that as well, it will take a little bit longer. And mostly, of course, it depends on the complexity of your application. So for example, if you start a Hello World application with Spring Boot, you will not see much of a difference compared to Micronaut. They will basically be more or less the same when you just measure the startup time. But as soon as the applications get more complex, then Micronaut can actually take advantage of it, and you will then see a difference there. So
can I interrupt you for a second, Tobias?
Yes.
So I'm going to paste in the chat. We have a couple of Spring Boot versus Micronaut comparisons with some projects that you can run yourself to get your own benchmarks, because
yes.
benchmarks, they are sometimes tricky to build. So I'm going to put a couple of links in the chat. So if anyone is interested about that, please check those links out and make sure to run those benchmarks on your computer and see. Mm-hmm. One important point is what Tobias was mentioning is Spring Boot applications startup time will degrade the bigger the application gets, right? So the Hello World application will be fast, and once you start building a bigger application, the startup time will degrade. Doesn't happen that much in Micronaut because we are doing everything at compilation time. Sorry for the interruption. I will just put a couple of links in the chat, and if anyone has any questions, please let me know.
Right. I think I know those links. It's basically a comparison of Spring Boot and Micronaut with outdoor integration. In our case, it's just the process engine, which takes the 3 seconds. Yeah, and of course, that's rather large time, but we're working on that. Okay, and the second comparison here is the initial heap size. So if you take Spring Boot and Micronaut, you will see a difference. Spring Boot will have about 300 megabytes on an empty application. Micronaut will have about 100 megabytes. That is a big difference. Probably it's the magic which is being done by Spring Boot during startup, and that can then basically be thrown away, because if you trigger the garbage collector, both will go down tremendously again after startup. And the third thing that you can measure is basically the throughput. So for example, the started process instances per second. It's hard to compare that because it mainly depends on the HTTP server that you select and its configuration. And it also depends on if you're calling blocking operations or not. So if you really want to compare something, you would really need a real life application which has a high complexity, and implement that in Micronaut and Camunda. And I don't have that up right now, so I can't give you any specific numbers on that right now. But it might be important, just to come shortly back up to the startup time, it might be important for you when you're doing test executions, right? Because I've seen a lot of Spring Boot applications taking 10, 15 seconds to start up. And if you're running integration tests, then it does make a big difference if your application starts in less seconds. Then we have some personal learnings here. So some things that worked well and some that could have been better. So what went well? I think if you're a Spring Boot developer, you can very easily try out Micronaut. It's basically very easy to use. The annotations are sometimes called a little bit differently, but besides that, it's rather easy. We found out that Kotlin is quite nice, so we're using it for all our tests. Just makes the code more precise, a little bit shorter sometimes. We're actually not using it for our core because that would mean that we would need the Kotlin runtime as well. So that's the reason why we're just using pure Java there. Oh, we also had a good impression from GitHub Actions, where we use it for continuous integration and the creation of releases. So using that quite happily. And we're also publishing to Maven Central via OSSRH. That's the open source hosting from Sonatype that works quite well. So I can recommend that. And things that could have been better, we started our project with Maven, and we noticed that Gradle is better, especially when you're using it together with Micronaut. And I've also had some people trying out the project with Maven, and they said that the process models were not found, for example, without a clean build, and sometimes getting failures. So I can just recommend using Gradle when you're working with Micronaut. And one last point here on the slide, there is a Micronaut project template which you can use when you start a new project. So if you intend to create a project which is going to be published maybe sometime in the future together with other Micronaut projects, then you should actually be using this Micronaut template. We might switch to that in the future. So we're now coming to a live demo. And I copied this process from Bernd from his book. It's a very simple process. It's a customer onboarding. We will look at the process in a moment. Maybe we just have a short look at the steps that we're going to do. So first of all, we're going to start from scratch with an empty project with Micronaut launch. We're going to add the dependency to our integration project. We're then going to configure the web applications, so Camunda, Cockpit, and the task list. And then we're just going to implement 2 service tasks, look at the UI of the task list application, and then also implement a message correlation. So you just get an idea of how the code actually might look like. Okay, so you can now see the Camunda modeler. This is the process that we're going to implement. So it starts with a start event. Then we have a service task. If we look into that one, we can see that there's a delegated expression here. So it's basically a bean that's going to be called when the execution comes here. Then we have a so-called user task. You can see that this has a different kind of icon here, meaning that this task will appear in a task list where a person will actually need to approve the customer order. And depending on if he approves the customer order or not, we will either go the path at the top and execute this service task, which also has a delegate expression, or basically end the process. And what we also have here is a so-called boundary event. When a customer cancellation comes in, this user task will be canceled automatically. So that's basically what we're going to implement. Usually you would use Micronaut launch here to create a project. So you can basically click this together, whatever you want, and then you can push it to GitHub or download the zip. I'm going to do it a little bit differently, because if you have installed your local Micronaut CLI client, then you can actually do it a little bit faster. So what I want to show you here is I have an basically empty directory. I only have a README and the process model. And what we're going to do is we're going to create an application called onboarding. And we then switch into the directory and we start IntelliJ with this process, with this project. Actually, everything's going to be a little bit slower now because whenever you share something in Zoom, the performance goes down a little bit, but I think it will be fast enough. So the first thing we need to do is add the dependency to our project. I have some live templates in here, so I didn't type all this right now, but it makes it a little bit easier. So what we've done here, we added the dependency to our feature project, and we also added a dependency for our H2 database. And the next thing I'm going to do is now actually add a process model. So you saw the process model previously in the top level directory. I'll copy it in here right now. Before I do that, I'll show you that there's no process model in there right now. I'll copy it in there, and now we have it available. And I'll do two more things right now. I will configure the application. And this configuration takes care of that an admin user is being created automatically. I will initialize telemetry here so that I don't get the question on the first startup if I want it or not. And I enable the web apps and the REST API. And we also automatically create a filter in the task list. We'll see that in a moment. And I need to do one more thing. If I'm going to use the cockpit, I have to switch the runtime over to Jetty because we currently don't support Netty. But if you're not using the REST API, and if you're not using the cockpit, you can actually use Netty, and that default will work pretty well. Okay, so that's basically it. We can now start our application. Just have to move that Zoom window away. And there we are. And we can log in. The cockpit is an application provided by Camunda, which you can use to have a look at your process models and the current state of all the executions. We can see that the process model has been deployed here. And what we can do now is we can start a new instance. I'll provide some kind of business key here. It's basically the primary identifier. I'll just keep it as A. And what happens now is that it's going to fail. Why does it fail? Because in the process model, we reference two beans. One is called score customer, one is called create customer, and those don't exist. So this is expected. It has to fail here at this point of time. What we do now is we implement those two beans. So the first one was called score customer. We annotate it with a singleton so that it's instantiated automatically. And what we also do is we implement the Java delegate interface. This is one of the many ways of doing it. But it's a simple way of doing it. And what I'm going to do now is I'm going to add a logger as well. And in the implementation, we are basically just going to log out some data. I'll log out the business key and I'll log it out on the warning levels because then it will be red, then we'll see it. And I'll do one more thing because this is the scoring place. We will actually save a result in a variable. So for example, we'll just save the value 99 here. Of course, this could be a complicated calculation, but for here, I think it's easy enough. And then we do the same again for create customer. Now I've got a typo in there. Result. And I'll delete that because we don't need it now. Okay, so
Tobias, can you show the contents of customer onboarding BPM? We have a question in the chat.
Of the BPMN file?
Yeah.
Well, basically it's this process model. Well, it is exactly this process model. And I don't know what the question is exactly. The question
exactly is, can you show us what's inside customer onboard BPM?
Yeah, so this is customer onboarding BPM. That's basically the process model with a visual representation. And technically this is XML. It's going to look like this.
I think that's kind of the question. What's that file? And it's an XML file. You normally operate on that with a visual modeler, but it's an XML file.
Yeah. So let's hope we answered that question. Okay. So what we'll do now is we'll now start the application again. And then we can basically go through the whole process. So we can see that we now managed to create the first user task. And if we look into the console, we can see that the first service task was executed. And what I can do now is I can claim the task. Please note, this is just a UI which you might use for rapid prototyping. There are ways to customize it, but of course you can also implement a very fancy UI and then use the REST interface of Camunda to have your own customized UI. I know it's called approved because remember previously one of the paths had the variable approved in there, and we can now complete it. And if we look into the console, we can now see that this process has ended successfully. What we'll do now is the last point. We will now also do the message correlation. So what we need now is just another bean. Let's call it message controller. This will not be annotated with singleton, but actually with controller, which is also a singleton, but it's a special singleton because it provides the REST API. And what I'm going to do here is this. So what we're doing now is we're basically providing an endpoint, which is called cancel. It requires a business key. And when you pass that business key in, it's going to correlate a process instance based on the business key, based on the message name, and then the process will continue as defined by the process model. The only thing that is missing here is now the runtime service again. So what we do here is we add that one as well. Note I'm using constructor injection. You should use that. Alternatively, you could actually just use the inject annotation there, but there are various reasons why you should actually use constructor injection. Does not only apply to Micronaut, also applies to Spring. Okay, so let's start that application again now. Screen sharing makes it slow. Sorry about that. It would actually be about twice as fast normally. So now we're back here, and we can see that we don't have a task yet, but we can start a new process instance here. I'll call that one A now. It's now available. We can open it. And what we're now going to do, we're going to call that endpoint. So we do a curl against port 8080/cancel. And now we must now provide the correct business key. I can't remember it. Was it A? I think it was A. No, small a. And we get the response canceled A. And if we now repeat that one, it's going to fail because the instance has gone. And if I repeat that, of course, it will not work. But if I now switch back here to the UI, I will see that the task is no longer existing. And it has basically gone because the message correlation from here has basically ended the whole process. Of course, you can model very complicated things with this. With this example, I just wanted to show that you can have service tasks, you can have user tasks, you can have message correlation, and then you can use Micronaut beans to basically wire all that together. Okay. Then we now come back to the presentation. So that was exactly what I showed you previously. You might now be interested how the magic looks like behind the integration. So I'll go over that rather fast. First of all, how do we actually provide our process engine and make sure that it started on startup? So what we have here is a factory bean, and we have a factory method here, which is annotated with context. This makes sure that the process engine is started together with the application context. And we also have our @bean pre-destroy close here, just to make sure that whenever the application closes, that the close method of the process engine will be called. So for example, to make sure that the telemetry data is sent out. Then the second slide is a little bit similar. It's a factory again. This time it's about providing the process engine's related services as lazy initialized beans. And the difference here being that we don't use the singleton annotation, the context annotation, but the singleton annotation, meaning the first time you inject this bean, it will actually be instantiated. Then the process engine integrates with Micronaut's transaction manager. How do we do that? So we create and we register a command interceptor at Camunda. And whenever a command is executed, our interceptor will be called. And within this interceptor, we inject the transaction manager and then call the execute method. The execute method requires two parameters. The first one is the propagation level. So that's basically the question if the existing transaction should be reused or not, or a new one should be created. We just take the value that Camunda requires, and we basically pass that on. And the second thing is we encapsulate the command here in the callback, which will then be called within the transactional context provided by Micronaut. So that's basically the place where we make sure that both use the same transaction context. Then Micronaut beans, which are referenced by the process models, are automatically resolved from the application context. So you might have an expression here like this one here. How do we do that? So basically we register an expression language resolver, and based on the property which comes in, we create a qualifier by name. So we interpret that as the name and then look it up in the application context. And if we find a bean which matches this criteria, then we return it. Otherwise, we just return the null here. Then Camunda's telemetry feature is automatically deactivated during test execution. How do we do that? Well, we basically just look if the test environment is active, and if it is, we automatically deactivate the telemetry because it doesn't make sense to execute that while the tests are running. And then the last one, I like that one quite well. So you can configure the process engine with kind of generic properties. I think you know that from the Spring Boot integration as well. And this would normally require reflection to set these properties on the process engine configuration. What we do here is we annotate the class with introspected, which means that metadata is generated during the compile time. And then when we loop over the generic properties here, we can use the introspection metadata to get the property and then set the value. So this is the way we're doing this without reflection. To sum this up, so workflow engines can complement modern microservice architectures. I think Bernd talked about that quite a bit. Then I showed you how easy it is to actually add our integration to a Micronaut project. Basically just add the dependency, your sensible defaults, and you can just go up and running. So in the end, we basically just provide you a further building block, which you can use in your Micronaut projects. Okay, so going to have a look at the questions in a moment. I just want to say now it's your turn. You can now try out the integration. If you're interested, you can register yourself on GitHub to be notified about new releases. We'll be very happy if you give us a star on GitHub, and feel free to connect us on LinkedIn, on Twitter. And of course, we're looking forward to your feedback and your questions. I only yesterday opened the discussion forum on GitHub, so that's another way of contacting us. Basically, you can go into this page here from GitHub, and there you'll find the open source project with a complete source code, with examples, and a getting started guide as well. We're happy to get feedback from you. The QR code here at the top right is basically the URL here, but if you just want to jump there right now, you could use it. Okay, so that's basically it. I think we were rather good on time.
We are, I
think. we have
a couple of questions.
Okay.
Yeah, let me introduce the questions because most of the questions are for you too. So we have a question which probably Bernd is the one who will answer it best, which it says, what's the difference between the open source version of Camunda and the enterprise version of Camunda?
I could use the screen sharing, but I make it shorter. There's a comparison on the website, so you can go into the details. The basic idea is that you can do real projects also with the open source version, but of course, there must be a lever or motivation for the enterprise version. I mean, we have to pay all the salaries of all the good people that built the software. And thank you, Tobias. And normally, if it grows bigger, so it might be a project that impacts, has more impact in the company. So you might need the support and SLA-based support and so on and so forth. Or if you want to have all these things around analyzing the data, which is written by the workflow engine, so you really can analyze and optimize your processes and so on and so forth. So these kind of features are enterprise only. Perfect,
thank you. Then we have a questions from Ragu about the Micronaut Camunda integration with Keycloak. So I may be able to answer this one. So Micronaut has support for OpenID Connect compatible authentication providers such as Keycloak. So you could use Keycloak or Okta or any of the others in the Micronaut applications. So the Micronaut Camunda integration is still a Micronaut application, right? So you can put security on top of it, and you can secure the endpoints accordingly. I think, if I'm not mistaken, what he wants to secure is the Camunda backend, the administration panel. You can secure those URLs using Micronaut security, using Keycloak or using any other security integration.
I'm not sure if you ever tried that, Tobias, but there's also a Keycloak integration for Camunda. I'm not sure if that works together now with Micronaut and Keycloak. So if all the things come together, correct. I never tried it.
I know that there is this integration, and if it basically implements the Camunda plugin interface, then you can at least integrate it.
So let's assume my expectation would be the same. It should work. So we have a Keycloak integration. Micronaut can work with Keycloak. So all the stuff together should also work. I would call it a should because I never tried.
Yes.
But if maybe Raghu will be the first brave person doing that, and then let us know in the forum. We're totally interested in that.
We have a question about how does a payment gateway work with Recurly?
Yeah, I saw that, but actually, I mean, it doesn't matter which external service you use. Recurly is like a SaaS service you use. So if you have a microservice connecting to it, it uses the API from Recurly, and that's it. I mean, it doesn't matter if it's Recurly or whatsoever.
Then we have another question about the Micronaut framework doesn't leverage a Spring framework. No, Micronaut is a different framework than Spring. So as Tobias said, if you are a Spring developer, you will feel at home because Spring brought into the Java ecosystem certain great patterns. And the team behind Micronaut is the same team behind Grace framework, which is built on top of a Spring Boot. So we do love some of those Spring paradigms, but Micronaut is a new take of a Java framework, like a modern Java framework. And yeah, it's a completely different thing. But the learning curve for any Spring developer should be a small one. Then we have another question, probably for you, Bernd. What can a business expect in terms of the onboarding experience?
So I relate that to the onboarding onto Camunda in a way of learning, like, what do I need to do in order to do the first project? And I hope that got a bit clearer with, I mean, Tobias did a great demo actually, because it really started at the beginning and you could see everything that you need to do in order to automate your first process. So it's not very hard. I mean, of course, you have to learn a couple of things, like, for example, learning the language BPMN and how to model certain scenarios. We try to improve the get started experience, also try to provide more and more patterns that help you get started. So I think that should be pretty smooth. I mean, always you have to give it a go yourself.
Sure. So there was a question that Tobias answered already in the chat about implementing Camunda external task workers using Micronaut, and I think you have an issue to do that, right, Tobias?
Yes. So in our code, we actually have an example where we implemented an external task worker with Micronaut. And I actually think this is a very good thing, because when you have external task workers, you often want to scale them up, you want to scale them down. And this is basically the optimal place to use Micronaut. And you don't even need the process engine in the external task worker. So this will be up and running in less than a second. And yes, we do have an issue in the sense of that we want to abstract the existing example, but basically it's working.
Perfect. We have a question from Anders about, will Camunda support Micronaut implementation as Camunda supports Spring Boot?
Not sure yet. I mean, what we normally do with this is a community extension. We love this kind of initiatives because it really allows to test the reaction of the market. So if everybody starts picking that up, yes, of course, I could totally imagine that we support it the same way. But it depends really on how people are picking it up. The Spring Boot extension in Camunda, the Spring Boot starter, was a community project in the beginning. It's not part of the core product. It's supported, and we do all the development, the further development on new versions. So that could be the same story. It could be not. Totally depends on the Micronaut community and how it's picked up.
I have another question called, what extra considerations should be taken when deploying to the cloud? How would service discovery plugins work? So this is in terms of a microservice architecture, when you have something like that.
Yeah, but I mean, from my perspective, not really. I mean, this is more probably relates to a Micronaut question.
So in terms of service discovery, we have support for service discovery in Micronaut. Probably the most common one that we have is Consul. We have also support in AWS for Route 53. They have like also like kind of a way to do service discovery, and also Eureka, the Netflix project. So I'm gonna send you a link to I'm gonna paste a link in the chat to a tutorial that we have for showing that how to integrate Consul service discovery with like 3 Micronaut applications. So that maybe what are the limitations of Micronaut integrations with Camunda WFE?
What is
I don't know.
WFE?
I don't know.
I think it's workflow engine. That would be my guess. That's a good question for you, Tobias, I think.
Yeah, I don't know if there are really limitations right now. Of course, they're missing features. If you look into the backlog, there are a lot of stuff in there. But I'm convinced that you could use the current implementation and use it. And I actually know of projects that are using it and who want to go live with it. So it surely depends on your use case, but
and I think one joker you always have is, I mean, it's integrated in your development project, and as well, Camunda as Micronaut are pretty extensible. So you normally, if you hit a roadblock, it kind of no, the other way. If you hit a limitation, it's normally not a roadblock. You can work around it.
There is a similar question, which is the integration fully ready or is missing some functionality? I think Tobias more or less answered this question already.
Yeah, well, I think you can basically go up and running for most use cases. So
what's ever fully ready?
Yeah.
Yeah. As with any open source project, and this happens to us in Micronaut as well. So we really welcome feedback, and I'm pretty sure Tobias welcomes feedback in his GitHub repository. So if you think the integration has any functionality missing, the best way to open the discussion is to create an issue and go from there.
Right.
There is another question about, is the plugin usable for Grails? Can it be configured for multi-tenancy? So correct me, Tobias, if I'm wrong. So Micronaut libraries are really easy integrated in Grails when they don't have any HTTP layer. So the Camunda Micronaut integration has an HTTP layer. So I don't think it will be out of the box dropped. Maybe the core could be like modularized and extended to do that, but I don't think it's right now like usable in a Grails application. There is another question about where are the business process testing with Micronaut integration? Are end-to-end testing and code coverage analysis possible? I don't know if the last question is a question about Micronaut or about.
Oh, that's I think about Camunda. That's the Camunda Plus person, I think, because we have these test coverage libraries, and we have a couple of examples also how they are integrated in Spring Boot.
I think they will actually not work currently because, to my knowledge, the coverage is based on JUnit 4, right? And we're using JUnit 5. So
could be, yeah. I lost track.
But you could probably use JUnit 4 and JUnit 5 at the same time as well. So that might work, but we haven't tried it out.
We used to support JUnit 4 in Micronaut applications. We have now like defaulted to use JUnit 5 for Java and Kotlin, but if you go to launch.micronaut.io, which is the homepage to basically create a new Micronaut application from scratch, you will get a project with JUnit 5, but I don't see any impediment to use JUnit 4 if your business requires that. Are there any integrations with monitoring frameworks? Does Camunda workflow engine, I guess, exposes its logs via an API?
There are a couple of possibilities. So one is that you really do the normal logging, like technical logging, that's always active, and you can configure that. You can hook in something to push events, like a process is started, a process ends to wherever you want to. So you could push that to Kafka bus and do whatever you want to. And we also have a couple of own integrations, for example, to look into all the data via reporting and these kind of things. So yes, you can do a lot of things there. There is also, if that question was more targeting like the tracing tools, distributed tracing tools like Zipkin and stuff, there's also, let's say, a couple of community efforts to get that working. So that's not out of scope, but also not out of the box.
There is another question from Luis about, do you handle concurrency gracefully if you deploy multiple instances of your microservices?
We haven't tried that out explicitly, but I think Camunda takes care of it, right? With optimistic locking exceptions and so on. So that should work out of the box.
Yeah. I would say yes.
Then we have a question from Prabhu. As a good practice, we recommend creating dedicated database for the microservices, so one database per microservice. Now that we use Camunda, we need to set up a whole bunch of ACT tables. Do you recommend creating Camunda tables in every database? Or do you recommend to use a shared database to access the Camunda tables?
Yeah.
This may lead to all services tightly coupled to the database that hosts Camunda tables.
So just to visualize the question. So if we have like 3 microservices, the default would be all of these microservices have their own database. And that means if all of them have a Camunda workflow engine inside, they need the related table in their database. And that means like in every of these databases, you have to create the tables required by the Camunda workflow engine. And yes, that would be always my default if I do microservices, because as it was asked, this really allows for isolation. That means that you can upgrade the workflow engine without asking anybody. You could switch the product for whatever reason. I have no idea why you should do that, but if you do, you could. So you're really isolated. Even your service, if it's going nuts with the load, for example, it cannot bring anybody else down. So in terms of isolation, that's the way to go. And it's normally not a big effort. I mean, we have all the creation scripts, create scripts. So you normally automate that kind of thing anyway. But that said, we have customers which are, how a CIO once put that, are not operationally ready to run that much databases. And then you might do kind of a workaround where you say, okay, now 3 or 4 microservices meet in one database where all the Camunda activity is happening. Technically that works with the downsides of not having the full isolation. But we have a couple of features actually to make that possible to run that. So while it's normally not the default, there might be reasons to do it.
Perfect. We have the last one. I think Tobias answered the other one in the chat. Is what are the next steps for the integration? I think that's a question for you, Tobias.
Well, until now, we basically concentrated on getting it running. And if you look into our backlog, so in the issues, you can see that we still have a lot of ideas. I think we're just going to wait for the feedback we're going to get from the meeting today. And we might look into the performance topic because I would like to get this really fast, and I do have some ideas for that. Maybe we can even use the ahead of time compilation feature provided by Micronaut. But for now, we're basically just waiting now for the current feedback to decide on the next steps.
Perfect. Yeah, I think we went a bit out of time. If anyone has any questions, please let us know. You can reach us after this talk. As we mentioned in the beginning, we are going to post the recording in our YouTube channel. I would like to thank Tobias and Bernd for taking the time. And I would like to thank everyone for joining. I have learned a little bit about Camunda and workflow engines. So hopefully everyone learned as well. And yeah, see you in the next webinar.
Thanks, everybody. That was great. I loved the demo. Thanks
to see you.
Thank you all.
You're around.
Bye.
Okay. Bye.
So a question in the chat, Tobias. I don't know if you know. So he's asking if you have tested the Micronaut Camunda integration with GraalVM.
Yes, we've tried that out. And basically it works. But we haven't invested that much time into it yet. Until now, you don't really get a performance improvement, which you would normally expect if you use GraalVM, because at least on the initialization, the Camunda bootstrapping of the engine is a black box, and it will not profit from the ahead of time compilation. Currently, you won't see any advantages, but no disadvantages regarding performance either.
So yeah, thanks, Tobias. I'm gonna end the recording, and I think this will upload the recording to Zoom. Again, thanks everyone who is still in the chat, and see you in the next one.
See you. Goodbye.